Yeah, good morning to all. In today's session, we are going to study about the basics of assembly language programming. So as we have studied in the previous session, how to program a assembly language. What are the various simulators we need in order to program assembly language and how the central processing unit or the processor will be executing it. So before going to the examples of programming or examples for assembly language, we should know what are the various instruction sets we have, and we should know what are the various addressing modes we can able to address, and what are the various directives that tells the assembler what it need to do. So we will just give an overview of what are the different instruction sets, addressing modes, assembler directives. So instruction set in this will be classifying what are the various instruction sets we have. Then we are going to study about addressing modes, and we'll be having to see assembler directives. Yeah. So first of all, what is an instruction? So instruction is nothing but what you need to do, right? If I give an instruction, sit from this bench to that bench, what you will have to do? You have to move from one place to other place. Similarly, an instruction is a binary pattern because your microprocessor understands only binary patterns designed inside a microprocessor to perform a specific function. So instruction is nothing but it is a binary pattern which is designed to perform a specific function. So for each and every instruction there will be a specific functionality. So the entire group of instruction that a microprocessor supports is called as instruction set. So we have for 8086 some more than 20,000 of instructions, as it is a complex instruction set. Okay, we'll see one by one in an overview. So classification of instruction sets. So there are 6 types of instructions that we need to study, that we need to know in order to program assembly language. First, data transfer instructions. Second, arithmetic instructions. Third, bit manipulation instructions. Fourth, program execution transfer instructions. Fifth one, string instructions. Sixth one, processor control instructions. First, data transfer instructions. With the name only you can able to understand these instructions are used to transfer data. So these instructions are used to transfer data from source to the destination. From one place to the other. The operand can be a constant, can be a memory location, can be a register, or any IO port address. As we have seen in the previous session, the instruction format, the first one will be opcode, then operands, then it can be a indexed, there can be a 16-bit, 8-bit data. Okay, we have seen in the previous session. So the operand can be a constant or memory location or register or IO port address. So for example, the first instruction of data transfer instruction is move, MOV, and its syntax is move, destination. It might be a register, it might be a memory, whatever. So destination operand, source operand. So it should be in this fashion. Move, then we need to write destination operand, comma, source operand. So here the source operand can be a register, can be a memory location, or immediate operand. Destination can be a register or memory operand. Both source and destination cannot be memory location at the same time. So either this should be register or memory location. When this is memory location, this should be register. When this is memory location, this should be register. So for example, how you can write move CX, 037AH. You already know CX is the count register. It is a 16-bit register. So this is my source. So this value is 037AH. This is without brackets, nothing but the 037AH is being moved to CX. Then one more example, move AL, BL. So source and destination can be registers but cannot be memory locations. Getting my point? So move AL, BL. The content present in the BL should be moved to AL. This is my destination register and this is my source register. Similarly, one more example, move BX, bracket of 03001H. Now here the bracket means it is address. 0301H is the address of the data being present. So it goes to this memory location which is 0301H. Whatever the content stored in this memory will be into the BX register, will be moved into the BX register. This is the first instruction, which is move. The second one, in the data transfer, we have push instruction. It pushes the operand into the top of stack. It pushes the operand top of the stack. And pop destination. Pop destination. It pops the operand from the top of stack to the destination. Into top of the stacks, pushes, pop. It pops means nothing but pull. It pops the operand from the top of the stack to destination. So destination can be a general purpose register, segment register, except a code segment or memory location. Example, pop AX. Next, we have exchange data transfer instruction, which are useful for exchanging the data between your source to destination. But it cannot exchange between two memory locations. It can be able to exchange two registers, one memory, one register, but it can't be able to exchange between two memory locations directly. Right? So this is the syntax for exchange, destination, source. Next, we have in nothing but if you want to give some address to the accumulator, specified address, then you can able to give the port address to the accumulator. It transfers the operand from specified port to accumulator register. So in AX, 0028H, nothing but it is giving the specified port address as 0028, which will be your accumulator. Next, out. So it transfers the operand from accumulator to a specified port. Now here accumulator will be your source and port address will be your destination. Simple. Inputting, outputting. Import, output. Next, LEA, nothing but load effective address, nothing but we'll be loading the offset address to the register. Nothing but it loads a 16-bit register with an offset address of the data specified by the source. So if you are writing some BX, it will be loading the effective address of the source into a 16-bit register. For example, LEA BX, destination index. So this is my address. So address of this we stored in your BX. Think about whatever the content present. If you are writing only DI address, if you are writing this one is in this content, whatever is there, that is loads into the BX register. Next, load data segment, LDS will be loading the data segment from the source to the destination. So it is a 32-bit pointer. It stores from memory source to destination register and data segment. LES load extra segment. Now it is a 32-bit data pointer which is loading the memory source to destination register and ES. So we have special instructions for loading a 32-bit pointer using your data register, which is LDS, and using the extra segment using LES. Then LAHF, which is nothing but load AH register flag, nothing but it copies the lower byte of flag register, loading the lower byte of flag register to AH, lower byte of flag register to AH. SAHF shift the flag register, shift the contents of AH to the flag register. Getting my point here? LAHF, SAHF. It copies the lower byte of flag register to AH. It copies the content of AH to the lower byte of flag register. Then push flag, it will pushes the flag register to the top of stack. Pop F, pop S, it pops the stack top to flag register. Pop F. So these are the data transfer instructions. Now we are going for arithmetic instructions. So as we all know, arithmetic instructions are useful for performing arithmetic operations on data. So there are 4 arithmetic operations which are addition, subtraction, multiplication and division. So first addition, we have add instruction. So using this add, you can able to add byte or word to word, byte to byte or word to word. So it affects the flags, yes or no? Because if you in addition, if you get carry or 0 or negative or overflow or auxiliary carry flag, all those things, all the flags will be affected by adding to byte to byte or word to word. For example, as we all know, this is my destination and this is my source. So now whatever the destination register have will be added with 74H, and again it will be stored in the AL itself. DX comma AX, AX comma content of BX. Next, second one in arithmetic is add with carry. If any carry exists, it will again added to the output and gives the result and stores the result in the destination register. Next, subtraction. Sub is the function, sub is the instruction which subtracts byte to byte or word to word. It also affects the flags. So we'll be having sub with the borrow also, which will subtract with borrow and give the result, and the result will be stored in the destination register. Increment source, it will be incremented the value from value by 1. Decrement, it will decrement the value by 1. The important one is AAA, which is ASCII adjust after addition. So after addition, it if it is going to the sum not in hexa format, it goes to the, it will be adjusted after addition. The data entered from the terminal is in ASCII format, which is American Standard Code for Information Interchange. So it follows ASCII codes 30H to 39H, again 40H to 49H. Remaining A, B, C, D, E, F, G will not be there. So it should be adjusted after the addition. Then other ASCII instructions are, we have AAS, which is ASCII adjust after subtraction, after multiplication, after division. Then DA, nothing but decimal adjust after addition. So as we have seen in the previous ASCII, here also it will be adjusted to the BCD code, BCD numbers. DAS, decimal adjust after subtraction, will be adjusted to the BCD numbers. Now, negative, nothing but it is used for making use 2's complement of a number. Negate. It creates 2's complement of a given number. It means it changes the sign of a number. Next, complement, to make the complement or compares. Compare, it compares two specified bytes or words. Multiplication, mul source. For signed multiplication, you need to go for imul instruction. For division, division source, and for signed division, you need to go for idiv source. Conversion, convert byte to word, convert word to double word. So these are your arithmetic operations instructions. Thank you.